My name is Imran Ullah. I'm a sales leader within our sales organization, kind of focused on Eastern Canada and Eastern US, and really trying to drive, transformational change with our clients. And I think a lot of people probably say that, but our approach is actually pretty unique, I think, in the market. And what we think when we think about transformation, we look at it from an engineering perspective. If you look at the makeup of our organization, we're primarily engineers, programmers, solution architects, data scientists that have come together and really kind of wanted to work with our clients on some of their most difficult problems and really think through them, thinking about how do we really start to leverage automation. And so what we've done is really kind of start to standardize and automate the stack, right? So if we can take some of the infrastructure challenges that our clients are seeing, around security, around kind of core infrastructure, and really drive that to better, automate and standardize that for an organization, and let the organization focus at the application layer or for their business or customer needs. And so that's where I think the secret sauce is for Centrilogic in terms of how we work with our clients to really leverage that. And what's interesting is that we are a global partner of Microsoft, and we've done a lot of really interesting work with them, primarily, around, AI and leveraging Copilot, and how to better leverage Copilot as a productivity tool within the team's framework, and as well as leveraging Fabric on the data side, and then Power Platforms to really think about how businesses can better leverage workflow. And we're seeing a lot of interesting use cases that come up, and I know that Shane's going to share some of that with you today. So I'm going to hand it over to Shane, and again, thank you for joining, and we look forward to, if you do have any questions, please shoot them in the chat, and we'll try to answer them as we go, but we'll try to keep this as conversational as possible. Shane?
Thanks. Okay, so we're going to get started. So my name's Shane Castle. I've been in the industry since the 90s. Spent 10 years as a developer, spent the 10s doing cloud, and the last 3 years has really been all in on AI. And so I'm really excited to bring this here to you today. We got some exciting stuff. So what am I going to talk about? First, I'm going to talk about AI landscape. It's in the news all the time. I'm sure many of you have heard of it and used it yourselves. I'm going to talk about prompts and prompt engineering and why that's important and how that works. And we're going to go a little under the hood on that. Then I'm going to talk about Microsoft Copilot and M365 Copilot in particular. I'll show you how many Copilots there are from Microsoft. Today's is focused on the Office M365 Copilot. Then I'll talk about custom Copilots and taking Copilot to the next level by adding additional functionality and automation. Talk about when it makes sense to invest in these additional Copilot projects. Then lastly, I'll be doing a demo at the end of the talk, walking through using M365 Copilot in a typical business scenario and questions. If you do have questions, please put them in the chat as we go, and I'll address them at the end, and feel free to stay on as long as you'd like to discuss questions at the end. So AI, where do we get here? How do we get where we are, and where did things start? So the term artificial intelligence was coined in the 1950s by a group of academics, and they thought at the time it would only take a few years until we had thinking machines that could do anything humans could do, and obviously it's taken a bit more time, but we're getting close. 30 years went by of research, and the evolution of AI became expert systems, which were rule-based systems. There were early machine learning platforms, but there was never really the promised thinking machine that could do everything humans could do, and that led to what they call the AI winter. So the AI winter was research slowed down, funding slowed down, and basically interest in AI kind of went away. But it was still there simmering. And an important thing in there was at this time, there was a researcher, Geoffrey Hinton, in the 80s, putting forward a technology that, as we'll come to see, became the key breakthrough into today's AI. Then with the growth of compute power into the 2000s and the launch of the cloud, we had much more compute power at our disposal, and this is where deep learning it came in, and the breakthrough there was a recursive neural network. So it's a neural network that could do back propagation, and that's that algorithm that is leading to a lot of this, and really driven by increased machine power, leading to the seminal paper in 2017. You can look this up. It's the paper that launched GPT. It's called Attention is All You Need. And I'll be talking about attention and why that's important in a few slides. But the key thing in there is the transformer, and the transformer is what takes attention into account. Then, of course, 2022, OpenAI released ChatGPT to the world, and for the first time in history, we had human parity text generation, very close to human level performances. Obviously, make errors, much like people do. And then 2023 and then 2024 and onwards, now that the architecture, the transformer architecture is known, Microsoft released Copilot. Other companies started releasing their versions of similar products. Google followed suit, X with XAI's Grok, Databricks, DBRX, and there are in the tens and even hundreds or more now LLM offerings out there in the world, and it's growing ever rapidly. The term you may have heard discussed is artificial general intelligence, and this is the idea of full human parity in all tasks that humans can do. Some groups believe this could happen in the next few years. Other groups believe it can never happen, and others believe somewhere in the middle. So it's something worth watching, and that term AGI is coming top of mind ever more so these days. So I'm talking about AI, machine learning, and deep learning. So ML is machine learning, AI, artificial intelligence. Artificial intelligence is the general scope of doing intelligent things or solving complex goals in complex environments. It is a general definition of intelligence. There are many definitions for intelligence, but put simply, it's getting things done in tricky situations. Where historically machines have not been very good at that. They're very good at rigid tasks in well-defined environments. What's changing now is they can do okay defined tasks, so defined in very complex, fuzzy, unclear environments, and getting things done in those environments. So the evolution from machine learning to deep learning, we talked about compute power, and then now the most recent big architectural change is generative AI. And I'll talk about each one of those going forward. So first I'll talk about what we now refer to as good old-fashioned AI, or GoFi, which is classic machine learning. And here are the major capabilities that have existed for decades, really, is so binary classification. If you have a set of data and you want to divide it in half, and you want to say, hey, what category does this go in, and what category does this go in? And a classic example of this is spam. If you have an email, you say, is this real email or is this junk? Does it go in the junk folder? Yes or no? That's binary classification. Multi-classification is a more complex version of binary, where you say, okay, I have this data. Maybe it's a customer. Is it, or say a stock in a portfolio? Is it a low risk, medium risk, or high risk? Or if you're an insurance company, is this a high risk policy, medium risk, low risk, that kind of thing? Or if you're doing marketing and you want to segment different customer groups, maybe you have 10, 15 segments that you want to categorize someone, a new piece of data comes in, and that would be multi-class classification. Next is regression. So this is math using a bunch of data and kind of finding a trend line, either a linear line like on a graph that fits through, or a curvy line, and saying, I want to understand how this data works. And let's say the price of a property for sale on your street. What should the price guess at the price that home would sell for? It may depend on number of bedrooms. It may depend on proximity to a school. It may depend on age of the home. All these kind of inputs get put into this regression model to build what leads to a forecast model. So regression and forecasting go together. And here we're saying, given the data we had in the past, let's talk about predicting the future. And all of these use statistics, calculus, linear algebra. It's a math heavy world here, trying to learn from the data. There are also reinforcement models. So here is where things are trained, say, to play a game or to perform a task. And the task, you can have supervised and unsupervised learning, but the idea is that the task occurs and the result is either given a reward or given a penalty. And a reward would be giving it a value of 1, and a penalty would be giving it a value of 0. So the model will make modifications to the formula as it tries different variations. And the more ones it gets, the more of that it will do. So the parameters will continue along that path, and that's called reinforcement learning. So this is has many applications, and this is how the most recent models today are learning how to do reasoning. So if you've heard of reasoning models in the news, many of the breakthroughs in reasoning are from reinforcement models. And there are many other models. I'm just covering a few of them here under the machine learning category, just to give an overview of what's out there now. But what leads to today's rule, and then there's rule-based models. So these are kind of more rigid, but there are definite use cases for rule-based models. These are like the evolution of expert systems. And here, if you have conditions, so if you think you go into your doctor, you say, okay, I have a sore stomach. It's like, do you have a fever? How is your blood pressure? And you set a series of questions, and these questions become the rules that come up with a diagnosis. And rule-based systems work very well in certain domains. They don't work as well in all domains, but in the domains that they do, they can be quite effective. Then we come to generative AI. So that was AI and ML classically. What changed is we have the diffusion models. So this is how we make images, and the most famous is DALL-E, or part of OpenAI's model, and then transformers. And this is where we get natural language processing, translation between languages, summarizing text, extracting key highlights, understanding the sentiment. Say there's social media posts and you want to know, is it a negative or positive commentary going on? And the largest example of the transformer technology is ChatGPT. And that GPT stands for Generative Pre-trained Transformers. So the transformer architecture, it's right there in the name. And this is what Microsoft Copilot is built on, this architecture. So what does generative mean? Generative means that it's predicting or creating new text. Pre-trained means that it's viewed all the data and the model has come up with a set of parameters. And a model is just a mathematical function. It's a polynomial, if you remember that, multi-term. So x1, x2, x3, x4, and just assign probabilistic values, or just a number, to each one. And you add all those up, and that's how it comes up with a prediction. The rise of ChatGPT and generative pre-trained transformers. GPT is the fastest adoption of a technology ever in human history. So this is a chart of different technologies that grew to 100 million users. It took mobile phones 16 years from introduction till there was 100 million users. The internet, just 7 years from introduction to 100 million users. Facebook, social media, 4 years. GPT, 3 months, just 90 days from introduction. There was over 100 million people using the technology. Never before a growth rate like that has ever been seen. So now I'm going to delve into the structure of GPTs. And the point of this next section is to give you an understanding of how this works under the hood, so that when you're working with Copilot and it behaves in a certain way, that you have a base understanding of what's going on and why that output may have occurred, just to help you use the tool better. So how do neural networks work? The idea here is we're transforming an image. So this is an image-based neural network. And this is how the human brain works as well. So if you're looking at these images all the way on the left-hand side, you can see a set of neurons. So each one of those circles represents a neuron. And this, if you think of a human, in the human eyeball, we have our optic nerve connecting to neurons in our brain. And in the human brain, we have 7 layers of neurons. That's how our biology is built. And so we have a 7-layer neural network. In between the output layer or the actions, there's what we call hidden layers. Now, not in the human brain, but in these math models. The idea is each one of these neurons gets exposed to a pixel or color, and each of these activating together leads to these next layers. And these next layers react to the reaction of the earlier layer. And as we move through the layers, all these complex interactions start to happen. And eventually you get to the output layer, and that's where you say, what is in this image? And the famous example is a cat. So the first early image neurons, neural networks were able to recognize a cat in a picture, and the way it did by training all of this data in the neural network. So there's a lot of math behind this, and this is where all of this runs on an NVIDIA, on GPUs, and that's where you hear NVIDIA in the news. This engine is extremely math heavy and requires thousands, millions, even billions of calculations to take place every second in order to happen. That's why the world is very GPU heavy, demanding right now. So there's many competing GPT products. There's OpenAI, of course, with ChatGPT, and Microsoft has a deep relationship with OpenAI, exclusive use of the OpenAI models in the enterprise market, and that's what M365 Copilot is built on. There are competitors, Gemini from Google. Claude is ex-OpenAI employees that have split off, and their company is Anthropic, which has been bought by Amazon. XAI is Grok product. Llama from Facebook. Facebook's created a open source version of this, or Meta. Meta's Llama, and DBRX from Databricks. Databricks has trained it in particular in case of data models. So there's a lot of competition out there. Microsoft's offering is really tailored to enterprise users, and that's what we'll be talking about today. So what are some capabilities of GPT models? For one, in general knowledge, it scored in the 13th percentile. There's a leaderboard and competition of ever-increasing models. The point being, you have human level knowledge in multiple domains. It would qualify as a lawyer. It's passed the LSAT. It would qualify as a doctor. It's passed the medical licensing exam. It's also a programmer, an accountant, a historian, philosopher. The point is, in many, many broad areas of human endeavor, that it has human parity capabilities. It does still make mistakes, and that's important to know. So now, getting into the details a bit more, and then once I'm in the details, I'm going to move into the Microsoft product here. But attention. Attention was the critical breakthrough in that 2017 paper where they figured out a way to solve this problem, which it has existed in computer science, in AI research since the 1950s. To a native English speaker, the bank of the river and money in the bank, it's very easy to distinguish that one is the sand beside the water at a river, and the other one is a building that you put your money in. As humans, we just naturally understand that, but programming this in a machine proved incredibly difficult. Of how do you get that understanding to happen? And the way they came up with it is the transformer architecture, the transformer algorithm, and the attention model. So attention is what solved it so that it knows what that is. So how does attention work? Well, let's start with what a transformer is and how a transformer works. So we're going to take the input text, the money in the bank, and the first thing we're going to do is chop it up into tokens. And tokens are the currency of the AI world at this moment. So you say, how many tokens per second can you process? The tokens are put together into embeddings. An embedding is a big table, a fancy way of saying a frequency table. Somebody added up all the numbers in the world, all the letters in the world that happen in all the data in the world, and assign a statistical probability to those numbers. And those become what are called the token vectors. And then the word order is added. So when you say money in the bank or the bank of the river, the position of the word bank is important in that sentence. And this is where they add the attention, which is another number, and that enhances the prediction. So we're just predicting the next word. And the result, one word at a time. So when you say start a story, it predicts the very next word, and all that gets fed back in, and another prediction is made. So it's just a continuous prediction loop. And that's how it works. So how does this look visually? First thing we're going to do, we're going to say write a story. So this is our prompt. Say, hey, GPT, hey, Copilot, write a story. First, we're going to split that into tokens. So here we have 4 tokens. And we're going to feed those tokens in. And we're going to assign a vector. So a vector, if you remember linear algebra, it's a position and direction. So it's a magnitude and direction. But effectively is a series of numbers and adds up to a number. And by doing this embedding model, you have millions and millions and billions of combinations of words. It's able to map a grid so that things like soccer balls and tennis balls go together, apples and bananas, fruits go together, buildings go together, vehicles, this kind of thing. And this is all mapped out in the vector data. This is a dramatic simplification of it, but it's essentially all boils down to numbers and probabilities of how often these things go together. So now taking that vector and adding in position, that adds an additional piece of information that shows it statistically which probability is going to happen next. So we push that into the transformer. The transformer runs softmax, which is a statistical measurement, and we say, what is the probability? What is the chance of the next word? If you write a story in English, there's a 50% chance we'll start with once. Once upon a time, there was and that is a reasonable place to start a story. Now we're going to take that once and we're going to feed it back in. So we fed it through the whole token architecture and we got out the word once. Now what we're going to do is take that, write a story once, and we're going to feed that back into the loop again. And what's going to happen is it's going to generate the next word. And then you have write a story once upon, and let's generate the next word. And then generate and generate and generate. And this is where you get generative AI, that we're generating all these responses. And that's how it works. There's obviously a lot more detail under the hood, but trying to strike a balance of technical understanding and simplicity here. But the whole key is the prompt. And the prompt is the input text that you give to the model. And that's what sets the probabilities starting. So the more detail you put into the prompt and the more context you give it, statistically, the words that it picks will be more likely. So this is if you take anything away from this seminar, is remember to build your prompts well. And so much so that's a skill of prompt engineering, and this is one of the most important things to learn in the world today, is how to ask good questions and how to properly put in the details, and the results you achieve can be remarkably different between a good prompt and a mediocre prompt. The output from the model can be night and day. So that's the intro to prompting. That's the history of how we got where we go. Now let's talk about Microsoft 365 Copilot. More of our science, yeah. Okay, so Microsoft 365 Copilot. First, I'm going to talk about 3 categories of AI in the enterprise. Data analytics is what we were talking about earlier with machine models, predictive classification, all that kind of stuff. The middle is where Copilot sits. It is a personal productivity chatbot. So it is really to help individual users be more productive doing their daily tasks. And then the third category is automation. So we do have an upcoming seminar on automation, and this is getting the machine to do complete workflows, including human in the loop, but more kind of taking decisions on its own, taking actions, reacting to data. That is what they call agentic AI. So if you've heard agentic AI in the news, that's really automation. Please come back to Centrilogic webinars. We'll have an upcoming agentic AI seminar coming up. And Copilot works in conjunction with agentic AI solutions. But today's M365 Copilot chat is really about individual personal productivity. So let's talk about Copilot in the Microsoft products. On the left, we've got Office, so Word, Excel, PowerPoint, Teams, all the tools you know and love over the many years. So Copilot for M365. Microsoft 365 is everything all together there. Dynamics, you have Copilot for sales, service, and finance. So this is tuned custom Copilots built into the Dynamics product to help increase sales, help salespeople be more efficient, service people booking information, following up with customers, all this kind of activities there. And finance, keeping track of the books, finishing reports, asking questions about cost or sales or any kind of financial information. Copilot for finance is for that. Within Azure, so Azure has the Azure OpenAI models where you can directly connect to the ChatGPT models via an API, and that's really what drives the agentic workflows and the automated tasks is through OpenAI. And there are many, many others. There's GitHub Copilot for developers. This helps developers boost their productivity. We have an upcoming seminar on that as well. Copilot for security, Power BI. There's many Copilots. There are so many Copilots that here is an example of them in Word. So Loop, Notebook, M365 in general, Teams, and each one of these Copilots, why it's called Copilot for Teams and Copilot for Outlook, is it's tuned and specialized to work in the context of that application. So the Copilot for Outlook knows about emails, it knows about calendars, it knows, and it's been trained on those kind of things, more fine-tuned than the other models. And that's not all of them. Here is a segment of the current Copilots in the Microsoft ecosystem. So it's kind of split into the 6 major categories. There are many around them. Data and AI, we had a seminar recently on Fabric, and that'll be coming up again. So if you want to check that one out. Data is a particular use case. Here today, we're talking about modern work, the bottom pie, modern work, M365 and all the Office tools. It will interact with the other ones, but let's stay focused on there for today. So that's M365 Copilot and how it fits in the Microsoft world. So now let me talk about prompt engineering, and this is specifically for M365 Copilot. So if you're using it in Word, in Teams, Office, etc., some things to know. One, Copilot, Microsoft takes security very seriously and has layered in multiple security and filtering and content guardrails. And so there are times where Copilot will say, I can't answer that, or I won't answer that. And a lot of it is doing either to security or to content ratings. Language-wise, it expects a formal tone. So, other AI tools can kind of produce humorous output, but Copilot's a serious tool for work. And remember the idea of topics. And the thing with topics is that there's a context, and this is a function of generative models, that they only have so much memory, much like a person. Once you go past and start mixing topics, and if you think of where that statistical model came up, if you start talking about one topic and you're talking about a different topic completely, when you mix those together, the statistical output will kind of be a mess. So this is important to keep that in mind. And then a lot of it is what do you want to get done? Excuse me. So if you want to learn about a particular project, you want to summarize an email, you want to create content, that's a great use case, updating or changing content, or in Teams. If you're using Teams and you want to catch up on something that's happened, that's a great use case as well. So when you're building a prompt, keep this slide in mind. These 4 things are very important. You want a goal, so be clear with the goal at the beginning. What is it that you want it to do? Next, give it context. And the point of this context is, again, where we're getting that probabilistic engine tuned up so that we're pointing it in the right direction. And say, I'm preparing for a meeting with a client and I want to discuss phase 3 of the brand campaign. So now it knows, okay, 3 to 5 bullet points, that's what you're going to get. Because otherwise, by default, it may give you a big paragraph and you're like, oh, this is too much information. I just want a few bullet points. Talking about this, and then source, where to go, where to read if you want it to read from documents, if you want it to read from some emails, this kind of thing, that go to the source and get that out. And then lastly is expectations. So when you put the expectations, put them at the end, and then that way, this is a clear prompt that'll work well in an office environment. The longer you make the prompt, the more detail you're going to get, and that is important to know. So as you keep going, you can continue to use the tool and keep adding in different prompts and save your prompts as well. Once you have a good prompt that works, maybe you want to run that monthly, hang on to those and share them with people. That's a great way to get things going. So here's an example of a simple prompt. So write a blog post about sustainable practices in our agriculture. Here's the same prompt, the same desire, but a much clearer prompt. And if you run these 2, the results are dramatic. The first one, you'll get a few paragraphs with some, if you just run this, you'll get a few paragraphs with some generic details. If you run this one, you're going to get a full structured argument with a introduction, leading paragraphs, the development of an argumented case, and then a summary. And you'll get the details that you're looking for. Now, if you aren't comfortable building this kind of prompt, you can ask Copilot to help you create the prompt. And this is a very useful way or handy way to get things done. Say, I'm trying to build a blog post. Help me build a prompt to get what I want. Ask me the things that that I want in my prompt, and then it'll continue to give you the pieces. And then at the end, you'll have the prompt. Start a new conversation. Put this prompt in, and you'll get the full output. Pretty much, probably exactly what you're looking for, and it's very good. So here's another one. The idea here is instruction, context, and example. So you can roll this in. So you're basically saying, here's what I want to have happen. Here's the context, and give an example. And then, or you can go context, example, instruction. The idea, and try different, this is the art part of the art and science of prompting. It really is an art. And when you find something that works well, hang on to that and keep developing it. But understand that there'll be very different output for these different questions. So here's a few more things that you can do with M365 Copilot. So you can recap a meeting, summarize an email thread, draft new emails, ask about particular topics or projects, particularly if your Copilot is connected to SharePoint. You have access to SharePoint content that you have access to. And this is important. Securing who has access to what information is an important thing of getting ready for Copilot. And then making updates to documents. So it's really just all around working in Office in general. So I mentioned security. Security is important, and it's important to understand how, when you connect Copilot to SharePoint, there are many environments where you have wide open access to documents, and often things are put in SharePoint and just forgotten about. So prior to a big rollout of Copilot, doing an assessment of your existing documents is really worthwhile, and particularly your existing security settings. And here's a bit of a roadmap on how to go about a rollout. First, you want to take a look and identify the sensitivity of data. Now, at Centrilogic, this is something we've been working with customers quite a bit on. What we have found successful is writing a custom Copilot, which I'll be talking about a bit. The custom Copilot goes in and reads all the files. So we create a secured environment where it reads all the files and assesses, is there sensitive information in here? Is there sensitive business data? And create an index, an inventory of all the documents in SharePoint. How old are the documents? Is there sensitive info in them? Are they still relevant to today's business priorities that the business has? And really kind of get an understanding of how many documents you have. Next is to put a classification on there and protections, so that we want to tag and group things so that not everyone has access to all the information, kind of limit information knowledge. And then update that and do some testing. And then use Microsoft security tools, Purview and others to extend that security throughout. So this is an important step if you're looking at bringing on Copilot. Here's a more in-depth view of how that security works. So how the query works is on the left, you have the tools, you've got Teams, you've got Word, Outlook. These are the clients, basically. The interface into Copilot. And what happens is when you type that information in, along with the context of documents or emails, those are sent to the Copilot engine, which in turn in behind the scenes calls the OpenAI client, and that's where the generated answer comes from. And then it also accesses your indexing and your Microsoft Graph. So the Microsoft Graph is all the connected information within your organization, and that's where getting that graph security down is very important. And this is where one user may have access to some information and other users may not. And the answers that Copilot generates will depend. Copilot acts in the context of the user that's asking for information. So if you have access to your OneDrive or your personal files, Copilot will have access to those, but somebody else asking information would not have access. And that's important to know. There are some questions that come up. Is your customer data, if you put your customer data in Copilot, will Microsoft take that for training? And the answer is no. They have the Microsoft Customer Promise.
What can I do for you, Kathy?
They got a bit of background noise there. So Microsoft does not absorb your customer data, and they have created audited reports showing that they do not retain or use the model. How is this different from ChatGPT? So Microsoft licenses the models, the pre-trained models from OpenAI, and deploys them within the Azure environment. And they have the enterprise promise. So they're completely distinct. OpenAI and ChatGPT is a completely distinct product, but it is the same underlying technology that powers Microsoft Copilot, but Microsoft operates that in a secure enterprise restricted environment. Okay, so now let's talk about Copilot Studio. So we see the tools in Office, and now if you want to extend that further and create your own Copilot that maybe, if you are doing customer service and you want a agent or a customer service Copilot to be able to answer customer questions, either directly to the public or to your customers, or just internally, a customer sales team, a support team may want to be able to quickly answer a question about customer information. This is where custom Copilots come in that interact with both Microsoft 365 or on their own. So here in those, when you're creating a chatbot, you may have worked with a chatbot in the past on a website where it's in the bottom corner and the little agent pops up and you click and ask questions, and the responses historically have been kind of terrible. And the reason for that is that those answers often are manually authored. So they are keyed on pre-selected topics, such as, my order is incorrect. Can you fix my my bill? Then that would trigger a response set, and that's in the manually authored topics. But really, this missed opportunity section, in red here, is where when people don't ask the question exactly the way that it was guessed, is where generative AI is now able to really make a difference. That chatbots can actually be smart and interpret what the user is asking for, and if it's within their purview of how to answer, can take action for the user or escalate that intelligently. So this is the model we're trying to move to, which is with a generative chatbot for customer service or sales or any function within your organization. You can still combine the manually topics. So if you already have a chatbot with manual and you want to augment it, or if there's particular ways you want certain questions answered, you can say, okay, when it's this question, answer it this way. But otherwise, in general, use knowledge of the documents and processes, and it'll figure out what answer it should give. There's also plugins. So if you use a lot of SaaS applications or enterprise applications in your business and you want to pull those into a custom Copilot, so you may work with booking software or ordering or shipping or any kind of whatever your supply chain or your business process map looks like, connecting these different tools together is part of what Copilot Studio can do. And again, here we're just trying to automate and speed things up, get things done automatically. Next, we have conversational AI. So conversational AI is that next level chatbot that understands, has context, and can work with all the underlying studios, all the underlying topics. So here we're connecting data, connecting all the Office apps, and on the right, connecting your custom enterprise applications all together. So you have one interaction with a chatbot, but behind the scenes, it's connecting to all different systems. It's pulling data from everywhere. It's taking action and making changes where required. And so how are these things built? What do they look like under the hood? There's a lot to this system. The point of this slide was saying that the Microsoft has this full architecture, and that this is really defined for building these agents and how to do these topics and coming in from whatever channel. So on the left there, you can see we've got, a Zoom meeting could be the interface. It could be Slack. It could be Microsoft Teams, any kind of different input channel talking through. And this is how these agents are built out. More, again, where data sources. So you may use uploaded documents, corporate documents that are secured. You may use data from a database. You may use SharePoint data or public websites as well. Do a search on the public. The idea is when a question is asked, the question comes in and it looks at what are the details of these questions. How do we go get the correct answer, which data source to use, and then summarize that together. I'm just going to skip along here. And again, the author topics, we're going to move through that. So let's just talk a bit about how to justify or when does this make sense to do. Here's the design engagement. I'm going to skip through this. Really, it's about how much time do you spend on a task. So if you do a task once a day and it takes you a minute, that's about 4 hours a year that you spend doing that. If you do that 1 minute task 8 times a day, it's about 29, 30 hours a year that you spend doing that task. And then down to the bottom, if it takes you an hour to do the task and you do it once a day, that's 220 hours a year or 1,700 hours a year you spend doing that task within the business. If you extend that to a team of 30 people, the numbers get bigger. Once a day, you've got 80 hours of it happening, and a 16-minute task, you're spending 22,000 hours a year of effort hours of getting that task done. Turn that into dollars. If you assume $45 an hour as a salary, for example, So if you have a team of 30 people that you're paying $45 an hour to, that spend an hour on a task, you're spending $2.5 million, give or take, to get that task done every year. So this is where the cost of building a Copilot that can supplant that task and automate that task away, if it cost $500,000 to save on $2.5 million in task, you got a 400% ROI in the first year, and then every year it compounds thereafter. So in, the 1 minute task may not be worth building a custom Copilot for. If M365 Copilot out of the box can resolve those issues, they may be there. But it's really those 30-minute, 1 hour tasks that can really be automated where you see real potential for return. Okay, so in the last few minutes here, I'm going to go start the demo, and maybe I'll take a quick look at the tasks, the questions. Anyone popping out? No, okay. So I'm just going to jump to the demo here.
Hey Shane, Ben had a question about hallucinations in pilot drafts. I don't know if you can see his question.
Yes.
Okay. He was just wondering if there's a way to reduce that, like false positives.
Yeah. So one, it depends on the strength of the model, and a lot of it will be the newer models, for example, GPT-4o, and particularly now 4.5, 01 and 4.5 and 03 have more reasoning. So in particularly for legal documents and legal contracts, there's a lot of intricacy in getting that right. You want to use a reasoning model, which is getting better. And then there's also what they call MOE, or mixture of experts. So if you use a mixture of experts model, so you'd have one model generate the answer, and then you have another Copilot instance that has been tuned to be a critic, and you give the critic the output from the first model to review, and you say, review this output, and then have it generate constructive feedback, and then you give that constructive feedback and the content back to the model, and it runs through again, and then you get a new output, and you give that back to the critic, and you can say, rate this contract from 1 to 10, or rate this contract for compliance to state law or provincial law. Whatever it is in the detail that you want, how would you instruct someone to ensure quality? Because if you think about that in general, the hallucination is a quality issue. So you want the quality of the output, so you get the agents to boost the quality. So I'll get back to a couple of the questions first. I'm going to do a quick demo of Copilot just so you can see it in action. So here I have a sample workstation, a demo workstation, and I'm going to start with Copilot for Outlook. So it's always challenging to do these kind of things, demos, because you need access to inbox. So here I have a company called Demo Company Inc. So it's a literal, the website is a demolition company, but it's for demonstration purposes only. And I have some basic emails in here. And let's go with this one. So let's go with a new email here. New features in February. So here is a big email with a bunch of features from February. I'm going to click this Summary by Copilot. So here in Summary by Copilot, it creates this real roll-up. So what do we have? We've got real-time prompt and chat, improvements on feedback, and some features are not available in Europe, right? And then here I can say, summarize my email from Microsoft. And what it's going to do is read these emails, because a lot of this is just sample stuff that I have coming in. So in a real mailbox. So I've got some accumulated costs, and if you just look at my email here, I have these cost emails. This is a sample AI model that's running in the background. subscription to schedule. So this is the kind of information I can get, provide some details on the accumulated cost. So here it's going to look into the emails and actually do a roll-up of that, and it's giving the details there of the scopes and this kind of thing. So if I do a new email, so that's the summary by Copilot. Here I get the draft with Copilot. Also notice I'm in New Outlook. So up in the top right corner, you can see that New Outlook button. So the new version of Outlook is the one with Copilot integrated. They are working on integrating it to the traditional Outlook, which is called Outlook Classic now. But here I'm going to say, what kind of prompt do you want? I'm going to do an announcement for the audience. Let's say for the sales team about new model year of cars. Let's say we work at an automotive company and I want to create some excitement about the new 2026 models. Now, in this environment, this is where you could pull in SharePoint information or give it other details to connect to. Or if you're talking about a particular a new product offering, let's say that you had a document ready and you wanted to announce it, you could include that chat, and then you could say, summarize this document in an email. So here, I hope this email finds you well. I'm thrilled to announce we're unveiling the stunning new 2026 model year. Exciting times for all of us. Encourage each of you. So there you go. And you can tweak this model, you could edit it, but that in general is Outlook in Word. So you can generate new emails, you can summarize existing emails, you can ask information about what people have sent you, and that's in Outlook. So next I'm going to jump to Word. So if I'm in Word, I'm going to do a new document. Okay, so now you'll see the newest versions of Word include this stuff. When you have Copilot installed, they've put it right here at the top. So there is also in the top right this Copilot button. But here, I'm going to say, create an outline for our company's new 2026 model year cars. They include hybrid options. So let's say that. And now if you notice in the prompt, I did a very basic prompt there. I'll say, expand this into full paragraphs. Base it on the launch of a new vehicle. So instead of dot product, so now you see it took that bullet list and it is making it into more detailed here. So I'm going to keep this and I'm going to save it, and I'll call it new car 2026. Okay, so now that I have this Word document, I want to make a PowerPoint deck for it. And I'll do a new deck. And again, here I'll click this Copilot button. And I get options. Now, there are some things here. You'll see I click Create Presentation from File. If you're doing this, you see Attach. And what it'll do is go to my OneDrive, but you'll see the file's not there yet because there is a little bit of a time lag between when you save a brand new file and when it shows up. And the way to get around that is if I go here into my demo company and I will get new car. So I right click and I say OneDrive and I say copy link. Okay, so I've copied the link to the file. I'm going to allow this, and now it's copied. And now I'm going to paste this in here. So here's my demo company Inc., all of that. And it's going to generate this. And while I'm in here, I have some more questions here from Max. Experimenting with ChatGPT, trade-off between detailed prompts and the AI looking to work around to. Yeah, so the prompting trade-off, so that's a real issue, and that's kind of the state of the art right now. So there's no blanket answer for that. I think it depends on use case, and depends on the nature of what it is you're trying to do. But this is where a multi-agent approach may be best. And this is another area. So our other talk, which is the agentic workflow, if there is some particular issues you're facing, you may want to take a look at Crew AI. And Crew AI is the idea of small specialized agents. If you have one agent that can do too much, you want to break it down into small tasks that it can get really good, and then pair those up together. And that is the one of the ways out there to solve the problem of how do you balance between gigantic prompts and not getting the answer you want. Make the prompt smaller but more specific. So a very clear, precise prompt for one agent, and then have it hand its output to the next agent that has also a clear activity. And that way you can test the agents individually too, that they're able to do their task as they go. So here you can see this PowerPoint that it generated. So, again, there's not a lot of details in here, but it's based on that Word document. And we got some new hybrid options. And here's just pulling stock photos. But you can see I was very quickly able to generate a Word document and generate a PowerPoint. So that is PowerPoint in Copilot in PowerPoint. So we're up to time here. I'm going to end there. If anyone has any additional questions, please pop them in the chat right now. Otherwise, thanks for joining. And join us for our next one.